Hi everybody, Mr. Lee here. In this video, I'm going to go over types of forces and free body diagrams. And free body diagrams can be shortened to FBDs. All right, let's get started. Now, a good place to start is the definition of a force. A force is either a push or a pull. Okay. Whenever something pushes or pulls on a different object, that is considered to be a force. Now, this definition can get a little bit deeper. For example, the object experiences an acceleration. So if you remember, an acceleration or object experiences an acceleration when it either speeds up, slows down, or changes directions. Okay, so if we want to go over a couple of the most common forces, now these aren't all the forces, but these are the most common types of forces that you and I will experience in this class. Now there are like a couple more like physics things that goes into some of these forces, such as like the different kinds of math that we can do, different kinds of formulas, but we'll get to all of that when we go a little bit deeper into those types of forces. But for now, we're going to just cover the basic types of forces. All right, so the first type of force is the force of gravity. Now, the force of gravity can also be called the weight. Okay. Now, this is where the differentiation between weight and mass come into play. Whenever you are taking the weight of something, you're actually measuring the force of gravity, right? And the force of gravity can be written as capital F subscript G or just a capital W. Okay, you will see it being written in both ways. The next one is the force of friction. Okay, capital F subscript lowercase f. Now, something special about the force of friction, other than its equation, is that it always opposes the motion. So, for example, if you have like rollerblades, or if you have an object that is moving towards the left, the force of friction will always point towards the right. Next up, we have tension. Okay, tension can either be written as capital F subscript T. Okay, or just a capital T for tension. Now, tension is unique because tension is a force that comes from ropes. Okay, force that comes from ropes, and tension can only pull. That's just something very interesting to think about. Like if you have shoelaces, you'll notice that with shoelaces you can only pull on the shoelaces. Whenever you try to push on the shoelace, or if you try to push on a rope, it just collapses on itself. Okay, you can only pull. Okay. Next up, we have things like air resistance. Okay. Sometimes written as capital F subscript AIR. Now, air resistance is a lot like the force of friction, except the force of friction comes from a surface, but air resistance, of course, comes from the air. And just like the force of friction, it always opposes the motion. Okay. Next up, we have the spring force. Okay, sometimes written as capital F lowercase s for the force of spring. And this one is also unique because a spring will usually oppose the force applied to it. Okay, so a way to think about this is if you have one of those clicking pencils, or if you ever pushed on a spring, right? Whenever you push on the spring, or if you click on the pencil or like a pen, okay, whenever you push down, the spring will always push back up. Or if you pull on a spring, okay, whenever you pull on a spring, the spring will always do the opposite, and it'll pull back in the opposite direction. Okay, it's pretty cool. All right, and the last one is like a generic term for any kind of force that you and I might do. For example, if you push on a door, or if you pull on a door, or if you like kick a ball, or if you throw a ball, that's just called a applied force. Okay? Just written as F, sometimes with a number like F of 1 or F of 2, determining on how many different kinds of forces there are. All right, and the last one, this is what we call the surface force. Okay, well, that's more of the definition. It's actually called the normal force. All right, and the normal force is a surface force, and there's a couple of very unique things about this. I'm going to go a little bit more into detail about this because it will come up when we draw free body diagrams. So the surface force, it is, well, let's go into the definition of normal. Okay, normal in math means 90 degrees, aka perpendicular. All right, now this is a force that you and I experience a lot. So for example, if you sit down on a chair, the reason why you don't go through the chair okay, is not only because the chair is a solid object, but the chair actually pushes you back. Okay, so right now you might be sitting on a chair or you might be lying in bed, and whatever surface you're on is pushing back on you, and that's the reason why you just don't go through the surface itself. Whenever you, like if you have your hand and you push your hand against the wall, the reason why you don't go through the wall is because the wall is pushing back on you, and the direction of this force is always going to be 90 degrees. Now I'm going to remind us that it will always be 90 degrees because that actually comes into play when we deal with the physics behind free body diagrams. Okay. All right. So these are the most common types of forces that you and I will experience at the beginning of this unit. Of course, there are a lot of different kinds of forces that will come up, but this is a good list. So let's get into how to draw free body diagrams. All right. So here I have a bird. Okay. Now you don't have to be an artist in order to be able to draw free body diagrams, because whenever you draw free body diagrams, you always want to start off with either a circle, okay, or a box, or a combination of the two. Here we have a box and a circle, and this represents the object itself. All right. So what I'm going to do is I'm going to just use circles. All right. So give me a circle here. So this is my bird. It's a very pretty bird. As you see, it's probably singing. Okay. So I am basically drawing all the forces acting on the object. Now, it's very important to know that I'm not drawing any velocity or acceleration vectors. Okay, I'm only drawing the forces. So if I take a look at this bird right now, this bird is standing on a branch. Now the branch is a surface. So what I'm going to do is I'm going to draw this object here, and I'm going to draw the surface right below it. Okay. Now, the surface itself is not a force, but it's like a reminder to you and I, and to anyone looking at your diagram, that this object is on a surface. So the very first force that we always want to draw is the force of gravity, and it usually goes down. I'm going to label it the force of gravity. Okay. And remember, this is the weight, so I'm going to write that W just as a way to remind you. But either F of G or W works here. And because this object, or this bird, is sitting on a branch, I'm going to draw the normal force. Okay. Now you might see it written as F of N or a capital N. Either way works. I prefer F of N. All right. So this is my free body diagram. Now a couple of things to notice. Because this object isn't going through the branch, the weight and the normal force, they look about the same in size here. And the reason why I say this is because the magnitude of the vectors, okay, the size of the arrows, actually tells us something. For example, if I were to have drawn this free body diagram, okay, like this, oops, make that straight vertical, okay, and make this weight like this. Oh boy, that should be straight down. Okay, if I were to draw something like this, what this is showing me is that the force of gravity is way bigger than the surface force, or the normal force. And so if I see this, what I am predicting will happen next is, because remember, a force is either a push or a pull, and right now it looks like the force of gravity is pulling on this poor bird way more than the surface is pushing back on it, is that this bird will probably go right through the branch, breaking the branch. And you know, we don't want that to happen. All right, so it's as simple as that. Let's do another one. Okay. So here's a different image, and this is actually an image that we will see a lot, and we will do a lot of math and physics behind it. We have an object here that is at the very start of this ramp, okay? And this object will roll down the ramp, all right? Now let's say in scenario A, we'll say there is no friction, okay? Just so that you can see how the free body diagram changes. All right, so the very first thing I want to draw is the object itself. So here I have the ball, okay, all right, and then I'm going to draw the surface. Now because this object is on an incline, I will draw the surface as an incline. All right, the very first force that we should always draw is the force of gravity, and that force of gravity always points down unless told otherwise, okay, and that is also known as the weight. Next, I gotta think to myself, is there any other force acting on this object? And the answer is no. It's just a force of gravity that is pulling on this object. downwards. But here we have the object on a surface right there. Okay, and because it's on a surface, there's a normal force. Now remind yourself, the definition of normal means 90 degrees, and it's always perpendicular to the surface. So if this is a surface, I want to start from there, and I want to go up and out like this. So I'm going to call that my normal force, and that's because if I were to draw this triangle, or excuse me, this square, which is a universal symbol for perpendicular, I create a rectangle right there. Okay, and that tells me that this is 90 degrees. All right. Okay. So in scenario B, let's say there is friction. Right? There is friction. Now, some cool physics things. If there's no friction, we say that the object slides, or it glides down the ramp. If there is friction, oops, the object rolls. Okay. And that's because the force of friction itself causes objects to roll. Cool little physics fact. And we'll go into that in a different unit. All right, so here I have, I drew kind of a little rough. The surface is rough. That was totally intentional. Not really, my hand got shaky. But to show the force of friction right there. All right, so here I have my object. And remember, the very first thing that we're going to draw is a force of gravity. And it's going to go straight down. Okay, the normal force, which will be perpendicular to the surface. All right, F of n. And just as a reminder, I'm going to draw the perpendicular symbol right there to remind ourselves that this should be 90 degrees. Now, when this object is rolling to the right, okay, well, more specifically, down and to the right, okay, this object is moving down and to the right, the force of friction always goes against that motion, and in this case, it'll be the opposite of down and to the right, which is up and to the left. Right? Ta-da! And that's how we will draw the free body diagram of this scenario. Let's do another one. All right, here we have a pretty funny image. We have it looks like a guy that wants to keep everyone out, and he is pushing against this door. All right, he is holding up against this door. Okay, so in order to draw this, I'm going to draw the object itself, and in this case, I want the object to be the door. Okay, I'm not going to draw the forces of, or the person here, or this lady here. Right, I'm not going to draw this guy here. Right, I'm only drawing the door. Now, the reason why I chose this image is this image has a lot going for it. Okay, I'm going to zoom in a little bit. All right, so I am going to first draw the door. Okay, and this is my image right there. That's the door. Okay, so if we were to imagine like the door is there, and without getting like too into it, let's go over the basics. So this door first has the weight, or F of G down. Okay, and let's just say this door is like on the carpet itself, right? And so we would have the normal force. Now I know there's like brackets or some things like holding it up, but let's just say that it's on the floor. Okay, just to make things a little bit easier for us. All right, now I'm going to draw the forces that is being applied by each of these members. So let's do it. I'm going to say this guy will be represented with the color green. Okay, so I'm not going to draw the person as a dot. I know that this person is applying a force to the right. Okay, so I will draw that. Like so. I'm going to call that F of 1. All right, and I will say anything on this side, I will represent it as red. So let's draw this guy. We'll call it number 2. So number 2 is pushing to the left, pretty hard. F of 2. Okay. We see this guy. We'll call number 3. F of 3 is also pushing to the left, but he's only using one hand, so I'm not going to draw that as big. Okay. And let's see. It looks like this lady here. Okay. She's also pushing while posing at the same time. All right. Photo op. Okay, we have F of 4, and I'm assuming that this lady, we can't really see her arm, but I'm assuming that she's also pushing on the door, either that or she's just like in a really uncomfortable position. Okay, and we have F of 5. Okay, she's not pushing as hard. It doesn't look like, it looks like she's just making the face to show us that she's trying really hard, but I don't think she actually is. All right, and the very last one is this lady right here, number 6. I'm not going to draw number 6 because notice number 6 is not touching the door. Okay, so here's a very important lesson. You can only draw forces that's impacting the object. Now this lady here is pushing on this guy, but she is not pushing on the door, and the object in focus is the door itself. All right, so that will be my free body diagram. Okay, so it kind of works there. Now, let's say we wanted to draw a free body diagram of number 2, Mr. 2. All right, and I wanted to show you this so that we can see how this lady will be impacting this guy. It's pushing like really hard. Look at his face. He's trying. Alrighty. So if I wanted to draw Mr. 2, I'm going to draw Mr. 2 with this dot right there. Okay, Mr. 2, he's got some weight, and he is on the surface. Okay, so he's on the surface, so we have the normal force. And we know that the door is pushing back on number 2. Okay, so Mr. 2 is pushing on the door, but the door's not going anywhere, so the door is pushing back, and we will say it's pushing him to the right. Now, at this point, you can write f of door if you want to remind yourself, but I'm just going to write it as f of 1, okay, fully knowing that it's the door pushing him to the right. Okay, and now we can draw lady number 6, and it looks like she is pushing him to the left. Okay, I'm going to label that f of 6 to make it match our image. All right, and the very last thing is I want us to take a look at his shoes, right? So if you push against something that is immovable or really hard to move, you'll know that the feet, like when you push against it, you're pushing against the floor. But what does his feet want to do? Right? He wants to slide underneath of him. So the object, his feet, want to slide, okay, to the right. But the force of friction will prevent that sliding motion because it's pushing to the left. All right, and I will label that up here as the f of f for the force of friction. All right, so there you have it. This is how we draw free body diagrams. It's a really important concept for the continuation of our unit. It's like the building block of everything that we're about to do. Okay, it is definitely something that you should spend time and practice doing. And trust me when I say it, if you draw free body diagrams, it really helps out with the math. So until next time, I'll see you later. Bye-bye.